All right, guys, number 16. So if they're giving you a percentile, plus they tell you that it's normally distributed, you can use inverse norm, and your area is 0.25. You want to change your mean to 45 and your standard deviation to 4, and that just gives you the answer. Okay, you can also shade the curve and kind of make sure that it makes sense. Okay, number 17 is just how you interpret a z-score. And a z-score is the number of standard deviations. So it would be 2 standard deviations lower than his average time, or D. Okay, number 18 is A, and you want to check bins, which is binary, independent, a fixed number of successes. And the probability of success stays the same every time. So the number of times out of 10, so we have a fixed number n, a particular child can throw a ball into a basket from 6 feet away. So we're assuming that if they stand 6 feet away, that the probability of success is the same every time. The shots are independent of each other, and you either make it or you don't make it. A lot of these are not binary. The colors of the car are not binary. The number of times a randomly selected resident of California has visited a museum, that's not binary. The number of cards drawn from a well-shuffled deck until all 4 aces have been found, that one's geometric. And the number of people surveyed until someone owns a parrot, that's also geometric when you do something until it happens. Okay, number 19. This is the definition of at least that I told you guys to memorize. So at least 1 is always equal to 1 minus the probability of none, which is D. You definitely want to know that. Number 20. So first you got to recognize this is conditional. So first you either take English or he doesn't take English. So we have English, which is a third, and no English, which is 2/3. And as long as you recognize that conditional on this next one, you know you can do a tree diagram. So if he enrolls in English, then the probability he enrolls in math is 1/5. So now we're going to go off the English branch. Math is 1/5, no math is 4/5. And if he enrolls in math, it's 3/5. Or if he does not do English, then it's 3/5 chance he does math, and then 2/5, okay? Then you have to be able to set up your conditional probability. So he is in a math class. What's the probability that he enrolled in English? What you know goes second. What you're finding the probability of goes first. And you want this bar for conditional that means given. So what's the probability he takes English given we know he's in math? This formula is on your yellow sheet for the AP exam. So it's the probability of English and math divided by the probability of the second thing, math. All right, so in the top you're going to multiply English times math, and in the bottom are all the pathways to math, so English times math plus no English times math. And you end up getting B for number 20. All right, if you can set up the table in this one, that would help a lot. So 2 dice are rolled simultaneously. So if you're rolling 2 dice, you've got your sum chart right there. If both dice show a 6, so that would be 1 out of 36 chance of that happening, then the player wins $20. All right, so our values go across here of how much we're going to win, and the probability of that happening goes underneath. So either going to win 20 bucks if we roll 2 6s, 1 out of 36 times, or you lose and you get nothing. All right, it also costs $2 to play, which we do at the end. So the expected value, you guys, we do this times this plus this times this, which gives us 0.56. But that's how much you would win, not counting what you paid to play. So you got to subtract your $2 that you paid to play, and the answer is D. So 22, hold on, did I skip one? Nope. All right, 22, so the central limit theorem. So for a large sample, regardless of the distribution of random variable x, we know it's normally distributed or approximately normal. A is the correct answer. The large sample they're talking about is a size of 30. B is incorrect because it's talking about just that it has to be normally distributed to start with. That's not true. Remember, it doesn't matter what the distribution is to start with, the population distribution, but as long as you're taking a large enough sample size, you know that it's going to be normal. So it is A. Number 23 is A. So this one was a little confusing. Usually our claim is the null hypothesis, but for this, the claim is the alternate because it's sort of the interesting one. We want to know, is that actually true, that over 60% shop there? And the null, you could say equal to right here, and then this would have to be greater than. So this would work with equal to, or you can say less than or equal to. Number 24, we're trying to do a confidence interval. And so your general formula is the statistic plus or minus the critical value times the standard deviation of the statistic. So all of them have the same mean right here, which they tell you that's your sample mean. And then you got to find the critical value. So since we're doing means, you want to use T star. And to find it, we do inverse T. Again, 95%, you take 5% and divide by 2 for your area. And means have degrees of freedom. So if my sample size is 16, our degrees of freedom is 15. And so we get this 2.13, which is in both of these answers. And then remember your formula for standard deviation, which is on the yellow sheet when you're taking a bunch of sample means, is sigma over the square root of n. But sigma we usually replace with S of x. And so that's our standard deviation from the sample, 130, and we plug in our sample size of 16, not 15. 15 is your degrees of freedom, so it is D. All right. This next one is B. What is the population of interest? We would like to get all the county residents, including the people without children, so B. Number 26, you've got 4 different temperatures here. You've got 2 styles of pans and 3 types of ovens. So basically we need every combination. So you got to multiply those together to get a total of 24 ways you could set all of those up. And so the answer is B, a completely randomized design with 24 treatment groups. We don't want to block on any particular thing. We just want to randomize all of our different variables. Blocking usually is when we know there's something that's going to make a difference. We might block on gender or something else. But for this one, it is just completely randomized design with 24 treatment groups. All right, 27. They're looking for a mean of 12 and a standard deviation of 2. So all of these that are skewed, the mean is like way off. Like here's 12. The mean would be somewhere over here. It is pulled left, but not that far left, okay? Same here, 12. The mean's got to be maybe right here. It's pulled left, but not that far. This one's pulled right, but not that far. So all of these are bad because of where the mean is. Both of these look good for a center of 12. What we're looking for is a standard deviation of 2. So you can start kind of counting. 2 down would be 10, and the next 2 down would be 8, and the next 2 down would be 6. The most important thing to look at is probably the third standard deviation, because you're going to get the furthest off. So we've got 14, 16, 18. This third standard deviation should really include 99.7% of the data, and it doesn't go far enough on that one. Whereas this one, if I go down 10, and then 8, and then 6, that's a lot more of the graph. If you go 3 standard deviations above and below, that includes most of the data. So the correct answer is distribution 1, which is A. Okay, this next one, This is one of the sentences that you really have to know for slope. The correct answer is E. For every year the car gets older, the selling price drops by $983. And the reason we do that is because it does say in thousands. So be sure you're paying attention to that. This one's talking about the y-intercept, so we don't want to use that one. And this one is talking about a percentage. So we got to understand what X is, and the selling price of the car is, or it's the price of the car in thousands. Or I guess that's the Y. All right, 29. So what's true about discrete variables? So discrete is when you want to think of like a table. There's spaces in between. So you can only get certain values and not anything in between those values. And the correct answer here is C. One way to check that it's actually a legit probability distribution is that it adds up to 1. This one also talks about adding up to 1, but it says the sum of all possible values of X. Remember, X goes on the top, and the probability of X goes on the bottom. These values up here could be anything. They don't have to add to 1. It's the probability of those that have to add to 1, so it is C. This last one was kind of a toughie. First, it's just understanding what it's asking. So the probability distributions are given in the table above. We have X and we have Y. So now they're going to add in Z where we add X and Y. And we want the probability that Z is less than or equal to 2. So it's all the ways we can add something from X and something from Y to get a value less than 2. So for example, I can add 0 and 1, and that would be less than 2. The probability of that is 0.4 times 0.1. We're going to multiply those probabilities together because I need to get a 0 and a 1, and that's 0.04. Okay, then I could get a 0 and a 2, these two numbers, which would be less than or equal to 2. So I'm going to multiply then 0.4 times 0.2, which is the probability of 0.8. And the last way would be a 1 plus a 1, which would be 0.3 times 0.1, which is 0.03. Those are the three ways we could get Z less than or equal to 2. And so it's this or this or this. We add those three probabilities to get B. I think you guys have seen this one before, so I apologize if this feels repetitive, but hopefully you remember how to do it. So first one's talking about the total in the bottle. So we're talking about the canola oil and the corn oil total. So when you add the means, you just add the means. So I got mu of t is 850, and I should do this first before I do this, but anyways, and then when we add standard deviations, this is our formula when we add two independent standard deviations. So I have 10 squared plus 15 squared, and we square root it. That's the total 18.028. And then we want the probability that the blend is going to exceed 900. It does tell us that it's normally distributed. So I can do norm CDF, lower bound 900, upper bound a big number. Mean is 850, and standard deviation is this 18 number, and we get 0.00277. All right. Determine the probability the amount of corn oil selected in the blend is greater than canola. So if you start like this, I want corn to be greater than canola oil. That means I can set it up also like this. Probability of corn minus canola has to be greater than 0. Now we're subtracting corn minus canola. So you are allowed to find mu d, where you just subtract 410 minus 440, corn minus canola. So on average, that's negative 30. Our standard deviation, you guys, stays the same. Even when you subtract, you have to add standard deviations. So if I were to do the formula again, I still would do the square root of 10 squared plus 15 squared and get that 18.028. Then we can do norm CDF, and I just want to get a positive number greater than 0. So 0 up to a big number, mean of negative 30, standard deviation of 18.028, and we get 0.048. So there's like a 5% chance that you're going to have more corn than canola in the blend. Okay, What is the probability that out of 5 randomly selected bottles of this blend, at least one of the bottles contains more corn oil than canola oil? So again, our probability of at least one is 1 minus the probability that none of them have more. All right, you got to know that formula. So none of them. Well, this is the probability that one of them does, so I have to do 1 minus that. And I need it to happen 5 times. Okay, so 1 minus 0.048 is 0.952 to the 5th power, and then subtract, and you get 0.218. You can also do this problem as a binomial because it either has more corn oil or it does not. And so it is binomial. Your trials would be 5. So out of your 5 fixed bottles, how many of them have at least one has more corn than canola? So your probability of success is 0.048. Your lower bound is 1 and your upper bound is 5, and we get the same answer.